Good evening again. Today, guys, we are discussing nonlinear programming. The past unit, we've been discussing linear, where linear, we're discussing the straight line, how to do a straight line, was simple and straightforward. So now we are moving from the linear functions. Now we are moving to the bit complex one, which is nonlinear, where we know when you talk about linear, we are referring to straight line, where we're using X and Y. In this case of nonlinear, that's where we know our linear function will always form a curve graph, where linear, it was just a straight line. And some of the examples of our nonlinear function, we can talk about your quadratic function, exponential function, and a trigonometric function. So those are our examples of nonlinear function. And we are saying nonlinear function, it's a bit more complex, or it solves complex problems as compared to your linear function. But also we are still doing the same thing, whereby we are interested to know the relationship between the two variables. But this one, it's more complex, whereby it's more of we're solving real problems as compared to linear functions. So under linear function, we'll start with let me go back to my study guide. Okay. So like I said, topic of the day is linear function. But this linear function, we are more interested in quadratic equations. The idea is still the same thing. We are applying these linear functions to solve the problem of economics or economic problems. Let me do this. Like I said, we are discussing linear function in economics. So in this nonlinear function under the economics perspective, we are more now interested in two things. We're interested in computing our total revenue. We are interested in computing our total cost. So our main objective today, we have to make sure that when you leave this lecture, you are able to compute and to do a graph of total revenue. And also you must be able to compute or calculate total cost. So the difference between these two, they give us profit. So after calculating these two, so now I think that is going to be easy for us now to do or to compute profit. And we are saying, starting with the first one, our total revenue. Total revenue, mathematically, we are saying the equation of total revenue is equals to P, and we are still familiar with PQ. PQ is still the same symbols or alphabet that we're using when we're doing a linear function. We still see our P as price. P still representing price, Q still representing our quantity. Our quantity. So we are saying our total revenue is equals to PQ, whereby we know that, okay, our P is equals to, if you remember from the function of demand, our P is equals to A minus AQ. This is our demand function from the previous unit. So now, for us, because now remember, I said to you, the nonlinearity, we are dealing with your complex equations, or we are solving the complex problems. So what we're going to do now, we want to have a quadratic equation of total revenue, where we know that our total revenue is equals to P times Q, which is your price times your quantity. So we are saying, since we know that the demand function, this is the demand function, looking at this equation. So we are trying to derive our quadratic equations given this information, where we say, okay, if P is equals to A minus BQ, then we look at the equation of the total revenue, where we say T R is equals to P times Q, where we say this Q, or this P, here is P. Our P is A minus B times Q. So we say, okay, in this equation now, as we simplify it, we say, okay, now instead of writing P, we are saying A minus B Q. Remember, this represents our P from the demand function. Then we have outside our Q there. So we want to write this equation as a quadratic function. So we multiply, when we multiply, trying to simplify it, we end up having A Q minus B times Q squared. So it means this is our new function, which we call it quadratic function for T R, which is total revenue. So from here, we are saying, okay, let's take an example. Look, okay, how are we applying this quadratic equation of total revenue? And if you look at from your study guide, we are given P there, which is price equals to 50 minus 2Q. So from this, we want to do our quadratic equation of total revenue. And we know that total revenue is TR. TR is equals to PQ. So since from the given example saying that P is equals to 50 minus 2 times Q, we look at our equation. So from our equation there, we say, okay, where we see P, now we put 50 minus 2 times Q, which is the same thing that I tried to demonstrate here when we are trying to derive the quadratic equation. So we do the same thing. We say, okay, T R is equals to, so now instead of now rewriting P, we'll be writing 50 minus 2Q, close brackets, times Q. So we simplify that. When we simplify that, we ended up having 50Q minus 2Q squared. So this is our quadratic equation of total revenue. So the interest here, we want to know what is the price. For us, for doing this, we want to know what is the price. We want to know what is our total revenue. How much are we going to sell our product for us to increase our total revenue? So that's the whole idea. So now we have our quadratic equation. So from our quadratic equation, we say, okay, Now we want to come up with our graph like we have done when we're doing linear equation. So from here, we have to do our graph. So we have our Q this side. We have a P there. So what is important when we are doing this one? We have to remember our properties of our quadratic equation before we can do a graph. And we are saying, first thing when you're doing our quadratic, this is our function, whereby originally, this one, if you look at it, it doesn't have a slope. Then we have, which is the original, plus c. So this function is still the same as this one. The difference between these two, we don't have c in this one. So we'll have another one where we find that we have c. So this is the standard form of our quadratic equation. So this quadratic equation is made up of our constant, which is we have a and we have b, we have c. Those are our constants. And we are saying a quadratic function has a minimum and maximum turning point. Where this maximum and minimum turning point, we are going to derive it from this equation. You'll see as we move on. And 3, we are saying the roots of the quadratic equation, which is this formula of a times q x squared plus b, x plus c is equals to 0, are found where the graph crosses the x-axis. To find the roots where we use the formula, this formula, Pythagoras theorem. The formula is derived from this. So we use that to find the values of x to a. So if we want the x-axis crossing the crossing, so this is the formula that we use. And when the quadratic equation can be factorized, we don't need to apply this. If it's easy, straightforward, don't need to apply. So you can just factorize and find the values that will represent x's in this Cartesian plane that we have. So we don't apply that. Number 4, the expression under the square root, which is this, we call it a discriminant. It's called a discriminant. The nature of the root of a quadratic function can be derived from the value of the discriminant, namely. So if you take the values, for an example, if you look at this function, and we have to take the values from this and substitute it here, and it happened, we are just focusing on a discriminant. And as we simplify that from this given information, and we found that the value is greater than 0, the graph has 2 different real roots. If we find the very same values that we subtract here or replace from this equation, they're equals to 0, we know that the graph touches the x-axis at the single point. The last one, if this discriminant is less than 0, the graph does not touch the x-axis. We'll see some of the examples of all the scenarios that I've been talking about them. So those are the properties of your quadratic equation. If you're using quadratic equation, you have to know all the properties, how to apply them. Okay. So let's go back and take another example where now we want to do a graph now using the total revenue. So to see why are we doing this total revenue? What is our interest actually for us to use quadratic equation? What is the objective? I will come back to this one. So let's say we are given a scenario where P is equals to 100 minus 2Q. So where we know that P represent price per unit, and Q there it's quantity produced and sold. So this given equation, this is your demand function. So we are saying from this demand function, what we want to do, we want to derive our quadratic equation of total revenue, where we know that our total revenue is the price per unit times number of units sold, which is our P times Q. So we know that from the demand function, the right-hand side equals to the left-hand side, meaning from this equation of total revenue, where we see P now, we can substitute that by what we have on the right-hand side. So which is 100 minus 2Q close bracket times Q. Then we simplify our function. Then we have 100 Q there minus 2Q squared. So meaning this is our quadratic equation. But why are we doing this quadratic equation? The reason we are doing quadratic equation, we are interested to find two values that will help us, which is the unit which is produced and sold, and what is the total revenue. So this is going to help us to have units which are produced and sold. That's number one. Number two, this is going to help us to have the total revenue that is made based on the units that are sold. So the first thing that you are going to do, if you remember the properties, now we have to find two values. So now we can be able to draw our graph. The values of okay. This is our quadratic equation. We have our Q, we have our P. So from this quadratic equation, we have to find the values of our Q axis or X axis. So one, we managed to come up with our quadratic function, if you remember the properties. So now we want to find the two values that are going to be on our q-axis. So we say x equals to minus b plus or minus open brackets. We have b squared there minus 4ac divided by 2a. So this is going to be the formula that is going to give us our x-axis. Because if you look at this, okay, there's another way where we can simplify it to find the values of x, but there's another way of doing it. So we say, okay, this is our formula. So we say, okay, based on what we have here, we are going to substitute this information that we have here in our function here. So we say b. We say b in this case, remember, we have, in this case, we don't have our slope, our intersect. So we say, because we don't have our intersect b, our b there will be negative 100 plus or minus. We have b, close brackets, minus 2 open brackets, which is our a there. It's negative 2. And our c is not there, then it's 0. Then divide by 2 times our a there. It's negative 2. Then we simplify. What do we have there? So we'll take it step by step so you can be able to see it. So here we have 100 squared there. 10,000. So this part, 2 times negative 2 times 0, that's 0. Divide by negative 4. So let's simplify our square root there. It's 10,000. We have 100. Then we have negative 100 there, plus or minus 100. Divide by negative 4. So the first value of x, whereby we are saying negative 100 plus 100 divide. We know that if you do that, we ended up having something like this. Negative 100 plus 100 divided by 4. The upper part, our denominator is going to be 0, then we don't have, then our x is 0 in that case. We know that our x is 0. That is the first x. The second x, where now we are saying negative 100 minus 100. In that case, I'll just do this. We ended up having negative 100 minus 100 divide by 4. Then we have the negative 200 divide by 4. Then we get the value of x, the second x. Then we have 50. So we know in the case of our q-axis, we have 0 and we have 50. So let's put our 50 here. Then we have 50. So these two values, they represent our Q.
Sorry, sir.
Yes.
Hello. I have a question.
Yes, I'm listening.
We got negative 50. Negative is not counted, right?
Pardon, no, I forgot. Negative, come again.
Oh, it was -4. Oh, okay.
Yes,
Got you.
I just missed the mistake. If you remember, if you look at from our workings here, you'll see that we had our A there. Let's go back. This is our A.
Yeah,
Our
got
A
you,
is
sir.
negative. Oh, okay, thank you.
Got you.
Sorry, sir. How did you cancel the square roots? I got lost there.
The square root, remember the square root is 100. We said, what is the square root of 10,000? So the square root of 10,000 is 100.
Okay, good. Thanks.
Okay. So now we have our values of Q. So we know Q is equals to 0, and again, Q is equals to 50. So here are the values. So what do we do now? We want our turning point. And our turning point also is derived from this formula, where we say our turning point there, Q, is equals to negative B divided by 2A. So it means, again, we're going to go back to our original problem. This is our original problem, our quadratic equation. So what do we do there? We take the value of A, rather the value of B. So the value of B in that case, we have positive. It was positive from the original, but because of our formula, it has a negative. So it's negative 100 divided by 2 times, now we have to go and look at for our A. In this case, our A is negative. So open brackets times -2. So now we are simplifying it. We have 100, -100 divided by -4. So we divide there, we say your 100 divided by 4. So it gives you 25. So we have 25. We know that our turning point is 25. But remember, as our turning point, we can have only one value as our turning point. So what do we do now? We know, okay, Q as a coordinate of our turning point, Q there is 25. So what do? We take that value of Q, which is 25, and we subtract it from our original problem. So this is our original problem, which is 100 Q minus 2 times Q squared. So now we can say, okay, in that case, we say TR is equals to, remember it's 100 Q minus 2 Q squared. And now we have the value of Q, which is 25. So in this equation where we see Q, we put 25. Then we have 100, open brackets, 25, the calculated 25, minus 2, open brackets, 25 squared. Then we simplify it. As we simplify it, we said 100 times 25. Then we ended up having 2,500 minus. Then we said 25 squared there times 2. Then we have 1,250. Then we want the difference, and the difference there is 1,250. So you go back. So we know if, okay, this is our Q side. Here we have 25. Up here, this side, for the pricing side, we have, actually it's not a pricing, it's total revenue, sorry about it. We have 1,250. So it means our our turning point will be here, where our so this is how our graph is going to move. So it means our graph, it will be passing from 0 axis going up and comes down, passes there. So, like I said, the two values that we're interested in, it was the value of Q, quantity of products that we are going to produce, and how much are you going to produce? How much are we going to make from there? So we know if we produce 25 units, then it means it's going to give us a total revenue of 1,500. So that's the whole idea of using quadratic equation. We want to have our turning point coordinates where now they represent units per quantity that you want to produce and sell. And when we sell them, how much are you going to create? So when we sell these 25 units, we ended up having 1,250. So that's what we made as a revenue from 25 units of the products that we sold. Questions? Questions? Questions?
No, it's still good.
No, we're good to go.
Okay. So remember, this was total revenue. So we are done with total revenue. Now we are moving to total cost. So we say total cost is a cubic function. So meaning when we are saying it's a cubic function, we have a power 3 plus b x squared plus cx plus t. So, which is a bit different if you remember where I said our total revenue is a squared plus bx plus c. So this one is quad, this one is cubic. So the idea also, we still want to find our turning point, and we still want to find what is here. We wanted total revenue, and we wanted quantity per unit. Quantity per unit that we produce and sell. So we can be able to have total revenue. So in this case, our interest is to find what is our total cost based on the units again. So we are still going to calculate the units, but now the interest is to see, okay, how are we going to minimize the number of units for us to minimize the total cost? Where this side, the idea is to maximize. We produce the unit with the hope of maximizing our revenue. Here, we produce minimum units with the hope of minimizing the total cost. So that's the whole idea of total cost and total revenue. So let's take an example of total revenue, rather total cost. And we are saying the total cost that is given to us is 800 minus 20 plus 5q squared. So this is what is given to us. So our interest is still the same. We want to find TC, and we want to see how many quantity per unit that we can minimize for us to minimize the total cost. So the first thing that we are going to do, still we have to find our turning points. Where, for us to find our turning points, one, we have to calculate our Q. And we know that after finding our Q, we can use that Q for us to calculate total cost. And you'll have to do your graph based on the given information. So for total cost, if we are saying, okay, calculate the turning point, the formula is still the same, which is Q equals to minus B divided by 2 times A. Where now we say, okay, this is our C. If you remember looking at this cubic function, we still have our C. I forgot to put Q here. So because of now we don't have cube, so it means it becomes C, B, A. So what do we do based on A, B, C that we have? Looking at this formula, it means in this formula we need B and A for us to have a turning point. So we go to that formula, to that given equation. So we say minus 120 divided by 2 times A. Our A in this case is 5.
Sorry, sir.
Yes, sir.
I would just like to ask, is Q equal to X?
Yes, in this case, if you look at your graph, Q here, it plays the role of X. Because if you remember, the original formula is X equals to.
Yes, that's why I got a bit confused. Thank you.
Okay, no, it plays the role of X. So we have, okay, if you look at your B here, from the given equation, it's negative. And also our formula, it has negative sign. So it means in this case, we're going to have negative outside and negative inside the brackets. Then when you simplify that, you ended up having 120 divided by 10 there. Then we have 12. So this 12, that's the units. So, but now we know, okay, we are going to produce 12 units for us to minimize the total cost. Meaning now, what do? We go to this equation of TC equals to 8 minus 120 Q plus 5 Q squared. Then we subtract 12 now, because we want to know how much is going to be the cost. 800 minus 120, open brackets, 12 there, plus 5, open brackets, we have 12 squared. So we simplified. Then 120 times 12. Then we have negative plus 144 times 5. Then you sum. What do you have there? It's okay. and 800 minus 1440. So that's our total cost. So from there, you can use the given information to come up with your Cartesian plane, where you can see that it means it passes through 800, then it goes down, where our turning point, it's made up of 12 units. And we know if we produce 12 units, we are going to pay, or the cost is going to be 80. If we put it in rands, 80 rands. So there's the total cost. Questions? Questions?
We still good, sir.
Yes, ma'am. Okay.
No, I'm saying we good. Thanks.
Okay. So remember, the whole idea is to find the profit. We are saying the difference between total revenue and total cost is equals to P, which is profit. So it means now we managed to calculate our total revenue. We know how to calculate our total revenue, and we know now how to calculate our total cost. So all we have to do now is to find what is our profit, whereby now we are given our total cost and we are given our price. Our price with the function of demand. So this subscriptive, it's a function of demand. So we are given total cost and we are given the price function. So we have to calculate our profit. So the given example says TC is equals to 200 plus 3Q and P subscript D there is 107 minus 2 minus 2Q. Okay. Remember, our objective is to find the profit. And remember, I said the profit is equals to TR minus TC. And this is the only information that is provided to us. So what do we do in this case? We still remember how we get our function of TR. Remember, we said TR is equals to PQ. So if PR is equals to TR is equals to P times Q. So we look at this function of demand that is given to us. So it means where we see P, we can substitute what is on the right-hand side. So that will be representing P in this equation. So meaning our TR there will be equals to this is our P times our Q. So what do we do now? We multiply to break the brackets. So now we know what is our Q. Sorry, our TR. So total revenue now, this is our total revenue, which is 107Q minus 2Q squared, where our TC is 200 minus 3Q. So we want to use this formula. Now we are fine. We have our our TR, we have our TC now. So what do? We say P equals to TR is 107 minus 2 Q squared minus. So we go to this formula to the equation of TC. TC is 200 minus Q3. So we open the brackets, 200 minus 3Q. Okay. So what do we do now? We are trying to simplify this part. So we'll just rewrite the TR minus 200 plus 3Q. So now what do? We group the like terms. So if you look at this equation, we have 10. Let me check something. Okay, it's plus, so it means originally it was plus. Okay, it was plus. So it becomes negative because it's negative times positive and becomes negative. So we group the like terms. So 107Q goes together with negative 3Q. So these ones, they don't have like terms. These two, they don't have like terms. So we ended up having negative 2Q squared. We want to put it in a proper order. So negative Q squared plus 107 minus 3 squared, 3Q. Then we have 104Q minus 200. So it means this is our function of P. P is equals to negative 2 squared plus 104Q minus 200. So from here, again, because now our interest is to know what is the profit. So we're going to apply the same method that we used when we wanted to find our turning point. So to know what is the profit, how much did we make? So we say, okay, from this given information, our Q is equals to the same formula that you know there, which is B, negative B divided by 2A, which is equals to, now we're using the given information. So our B in this case, here is our B. It's negative 104. We have 2, our A in that case is negative. So we simplify. When we simplify, we ended up having 26. So our Q is 26. So we take this value of Q and we're going to substitute it from this P equals to negative 2Q squared plus 104Q minus 200. So we say P is equals to negative 2, open brackets 26, plus 104, open brackets 26, minus 200. Then we simplify it, then we have 1,152. So that is our value, which is our profit. Questions?
So I would just like to ask if we would ever have to get the minimum profit or anything like that.
Pardon? Come again?
Would we ever have to get something like minimum profit for a firm to Yeah, for a firm to get minimum profit, if it's a negative quadratic function.
Oh, I've never come across that. Never come across where we find our P, our P, which is profit in this case, negative.
Okay,
But I will
thank you.
check if there's any, I will check, but I've never come across whereby the profit is negative. But we know if we ended up having a negative value, it means that indicate a loss.
Yeah, so it doesn't make sense for it to then still be called a profit.
Yes, I agree with you. Questions? No questions. If there's no question, let's take another one where you're also calculating the price, the profit, I mean, where we are given Q minus 2.5p. So this is the function that is given to us, which is a demand 1. And we are also given a total cost of 120,000 plus 400Q. So the interest is still the same. If we're given this, so it means we'll have to find our total revenue. And our total revenue is not going to change. It's going to be P times Q. So it means what is given to us, if we're given a function like this, the idea is not to change it, just to look at what is given to us. Just to remember our equation, our function or equation, then we substitute it. So now we can be able to derive our quadratic equation of total revenue. So in this case, if TR is equals to P times Q, and we are given a demand function of Q equals to 2,500 minus 2.5p, we do what we have done previously, where we say, okay, we are given Q, so open brackets. We say, okay, where is Q now? We put 2,500 minus 2.5p, close brackets. Then we simplify it. So if you look at previously, the case was whereby, okay, we are given P, but we are finding our quantity. But now it's different. So now we want our P. So here we say, okay, we multiply. When we multiply, we end up having the function of 2,500 P minus 2.5 P squared. So this is our quadratic equation. So it means we're going to take this quadratic equation and also this given function of total cost for us to find the profit, which is P TR minus TC. Where now we say, okay, this is our TC. So, and we also have Q here. And you look at, this is the function of our TR. So we want to have similar function. So what do we do because we want to have similar function? I'm looking at this one now of total cost. So it means total cost is made up of 120,000 plus 400Q. So it means now this equation is going to apply in both equation of total cost and also the equation of total revenue. So what do? We manage to come up with this quadratic function of total revenue. So we have to do the same in case of total cost, where we say, before we solve this, where we say TC equals to 120 plus 400 Q. So our interest is Q. So from the demand function that is given to us, which is this one. So where we see Q in these two equations, we substitute that with 2,500 minus 2.5p. So we have done that here. So we are going to do it again here. Now, instead of now writing Q, we put 25, 2,500 minus. Okay, then we simplify it. Then you say 400 times 2,500. Then we'll be having, is it 1, 6? Okay. Minus, then we multiply 400 times 2.5. Then we have 1,000p. Then we group the like terms. So these are the like terms. Then we have 1.1 minus 1,000, 1,000p. So this is our equation for total revenue. So we have our new total revenue, and we have not revenue, sorry, we have total cost, and we have total revenue. Okay. So what do we do now? We say P equals to TR minus TC. Where we have 2,500 P minus 2.5 P squared minus, open brackets, 1120 minus 1,000 P, close brackets. Then we simplify it. Then we have 5P minus 2.5 P squared minus 1.12000 plus 1,000 Q, 1,000 P, yes. So now we simplify it, we group the like terms. So this goes with that. Then we'll have negative 2.5 P squared plus, this is 3.5 minus 1.12000. Okay, so this is our function. our quadratic function, but we are not done. Now we have to calculate our P. So how are we going to calculate our P? We're going to use the same equation that we used when we were calculating the turning point, which is P now. It becomes P because our interest is P. P minus B over 2 times A, where we say, okay, our P in this case is negative. So we have 2 times negative 2.5. Then we simplify it. When you simplify it, we end up having 2 times 2.5. We have negative 350 divided by negative 5. Then we simplify it. That negative, which will go and that will go. Then 350 divided by 5, we have 700. So we know from here what we will do for us to know what is the maximum profit. We are going to take this and substitute it from the P equals to negative 2 squared plus 3,500 minus 1.12. Okay, so where we see P now here, because now we want P maximum, we put 700. Then we ended up having negative 2.5, 700 to the power 700 plus 350. I think there must be P here. Then we put 700, close brackets, minus 112. Okay, then we simplify. When we simplify, we say negative 2.5 times 700 to the power. Then we have negative there, 1,225 plus and 700, 2,450 minus 1,1,200. Then we want the difference. When we say negative 1,150,000 plus 2,450 minus 1,120,000. Then we have 105,000. So this is our maximum, P maximum. At a price of 700. So this is the price. So if we decide to sell with the price of 700 and the units that you are producing, so we can make this maximum profit. So this is the price of the units that we are producing or product that we are producing. Now, after producing it, we are saying, okay, that unit, we are selling it 700. And when we are selling it with 700 Rand, okay, we stand a chance of making this maximum profit. Questions? Questions? Guys, questions?
From my end, there's no question. Thank you.
There's no question. Okay. Others?
No question, we still good, sir.
No questions. So if we don't have questions, okay, let's meet when we are doing, I think we'll be left with few things, then we'll be done. Okay, so a hand. You can talk, we're listening.
Yes, sir. I was just wondering, maybe can you share a bit of past papers, because I'm trying to find them, I can't find them. Can you maybe share past papers so that we can keep practicing, because our study guide only has so much.
Okay. I'll talk to the primary lecturer so we can make that information available.
Thank you.
Okay. Questions? Okay, if there are no questions, let's meet on Wednesday.
Thank you, sir. Enjoy the evening.
Okay, thank you. Bye.
Excuse me. I have a
Okay, I'm
question.
listening.
What learning unit will we be doing on a Wednesday? Because I was under the impression that we'll be doing differentiation, but it's not the case today.
Yes, we are. I think Wednesday we'll be finishing. We're going to do differentiation, I think, on Monday. Yeah, next week, Monday, we'll be doing differentiation. So it means next Wednesday we'll be doing, let me see, we'll be doing cubic function already, but we started with cubic function. We'll be continuing with cubic function and break-even point, equilibrium. Yeah. Let me see.
Okay,
Yes,
so
and exponents. Yeah. Then I think after exponents, yes, we'll be going for differentiations. Yes, we'll be going for
Thank you,
differentiation,
sir.
which is likely next week. Okay. Okay, let's meet on Wednesday.
Yeah.
All right. Thank you. Thank you.
Okay, bye.
Thank you.
Okay, bye.